Here we can see the detail of how the PAW function is actually implemented in C++. So I'm gonna go through this very quick, but the implementation is not important here. We are looking at how basically this is invoked and how the result is being returned. But basically what it is doing is that we are getting some product and I, and it's gonna loop basically from 0 to arg1, and every time it's gonna multiply arg0 by product. So what is it doing? Basically, it's calculating a power. So for example, if you give it here 2 and 3, it's gonna calculate 2 to the power of 3. And how it does that? It's gonna go from 0 to 3. So basically for 3 times, this loop gonna run. So that's gonna be this number here. And every time it's gonna multiply arg0 times the answer that we have. So starting from 1, so that means if it's 2, first it's gonna be 2, or 1 times 2, so it's gonna be 2, this answer. The next time gonna be 2 times 2, gonna be the product gonna be 4, and then the last time it's gonna be 4 times 2, so the product gonna be 8, and it's gonna return that value. But again, the implementation is not important here. We're gonna look at how the mechanism of basically getting the code flow to here and then returning this value is working. The important point is that we can write this independently of our main function. So we don't need to know how the main is implemented, and also main doesn't need to know how this function is implemented. So there are two separate entities. The way they communicate is through the standard that we set up. So we have some convention that where the argument should go and where the return value should be, and how we're gonna like keep or protect this return value. And that's is gonna be basically the way that these two gonna communicate. So as long as you keep that and basically keep all the conventions, you're going to find and you can basically call this function without any issues. And of course, having or writing code in this manner helps you to have kind of like independent modules that they can basically each handle a specific logic without making your code very complicated. So you can break up your code into these smaller modules or functions here. So here we're gonna see the translation of that function, and there is some limitation. So for example, if you are putting this one and then you have your main at some point, you should make sure that this loop and exit are not being reused anywhere else in your code. So these are supposed to be unique in your all of your code. So that's something to just keep in mind. And another thing that is important here is that this is kind of a special case, and that is because this PAW function is not calling any other function. So if you look at through this code, you don't see any jump and link instruction. So this function is not invoking any other function. And that's why we are calling this a leaf function. That means if you put your kind of like code execution in a tree, you're gonna see that this function is not calling any other function. So leaf functions are easier to basically handle because you can put all the registers, all the variable that you need in your T, and you're gonna be fine as long as you're not touching like S register or anything like that. And you can use all the T registers, and that's gonna be fine basically. We're gonna see why I'm saying that when we are dealing with the like not a leaf function, because this is kind of a special case. So Also, like what you can do in leaf function is that you have the v0 for the return address, right? So you can directly use that from beginning, as you see here, and you can put your answer and keep building it. So they had something like that here. So you have like product here defined, and then you are using this product, and then you are returning the same variable. So here we are kind of doing the same thing. We have this v0 that is our product, and from beginning you are doing that, and you're at the end, you're just doing jump register and you're putting a return address. So you're not worried that it's gonna be erased basically by different functions. But let's skip the implementation of it. And there's two biggest piece here that is basically shared in Leaf or basically any other function that we are writing. One is the label, that here is basically how you call your function. So this should be, so basically like the name of the function here. So if you wanted to call this function, you do jump and link and then POW. So that is the label. So that's one important piece. The other important piece is this last line here. So jump register and RA. So again, RA is a return address that we have for going back to like our main or where this function was called. And jump register basically take that address from this register or any register that you give to it and put the global pointer to there and or program counter to there, and the program gonna continue executing from that point. So these are the two very important piece here. So now let's look at a more general case that we're gonna have some kind of like nested function call. So here the goal is to compute this equation. So x4 plus x3 plus 1, and you have some loop, so x going from 2 to 4. And every time you're gonna like output that value. So what happens here is that you're calling, so this is your main, and you're calling this poly. So this is another function that we're introducing. And let's look at poly itself. So how basically this is implemented. Here you see that we have the POW function. So now this poly function is not actually Leaf anymore, because poly function is calling the POW function. So here it's gonna get a bit tricky. So what is going to happen if we are looking from here? Let's look at this line. So when we are calling poly, we have the return address set to this location. So gonna be like the next line. And then we are executing here. And once we get here, we have the POW, and POW is going to, we are doing a jump and link, and that's gonna set the return address to this line. So that's fine. We return from POW, we come back here, and then this one is going to set the return address to the next line. So again, we run POW, and then we come back to this line, and then we get to return here. So now the return address is actually set to here because this POW updated that return address. And in this case, we lost the actual or original return address, and there is no way that we can go back to this location anymore. So it's gonna be kind of broken. So how do we fix this? The way to fix this is to use the stacks as we looked at them previously. And basically, the short answer is that you save your return address onto the stack if you are not a Leaf function. So we're gonna see how actually to do that. And also something that return address is not the only thing that we want to save. So more on that in the next slides.